Logarithms, graphing logarithmic functions. Since logarithms are inverses of exponentials, whoops, the graphs of logarithmic functions and their related exponential functions are reflections across the line y equals x. So we're going to graph two functions on the same grid here. And there you can see those two functions. They are inverses of each other. One is an exponential, f of x, and one is a logarithmic function, f inverse of x. So I'm going to do the exponential in orange and the logarithmic function in green. If we plug in values for x into f, when x is 0, 2 to the 0 is 1. So we have a point here at x is 1. When x is 1, 2 to the 1 is 2. When x is 2, 2 squared is 4. When x is 3, 2 to the third is 8. And that's all we're going to be able to fit in that direction. 2 to the negative first power is 1 over 2, or 1/2. 2 to the negative 2 power is 1 over 2 squared, or 1/4. And then 1/8, and it gets small quickly. And so this graph is going to go just like this, as we have learned exponentials do. And the asymptote is right here at y equals 0. Now, we said that functions and their inverses are reflections across the line y equals x. So I'm putting that line in right here. That is the line of reflection. And so what we can do is we can take every point and look at it across the diagonal. How far away is it from this line? So this is one diagonal unit. So we can go one diagonal unit over here, and there's a point on the inverse function, which is f inverse of x is equal to log base 2 of x. We can take this point, and that's a half unit. This one is one full diagonal unit. So right there. This one is 1, 2, 2.5 diagonal units. 1, 2, excuse me, 1/2, 1, 2. So that's 2.5 right there. And we can also see, for instance, that this point 3, 8 is reflected across the line to become the point 8, 3. This point 2, 4 is reflected across the line to become the point 4, 2. So those x and y values just switch places. Similarly here, it's going to go to right. That's -1, -1/2. So it's -1/2 is -1 right there. And again, it's going to go down that direction. And so what we can see is that the inverse, the logarithmic function, has the asymptote right here at x equals 0. And yeah. The next one, we're looking at a little bit more complicated exponential function. And it says here, in exponential function transformations, we saw that all transformations could be represented as vertical transformations in the equation because logarithms are inverses of exponentials. All transformations can be seen as horizontal. I'll have that fixed in yours. So this should be as sorry about this, as horizontal transformations. All right, so sorry about that. Thank you for bearing with me. You're so kind. So, this one, so this 2 to the x is the same as we saw above, except for the 3 stretches it vertically, and the 1 raises it up 1 vertically. So the new asymptote is going to be right here at y equals 1, because the k value there is 1. And then because of this 3, instead of going through the point right here, which would be 1 unit above the asymptote at x equals 0, we go 3 units above the asymptote at x equals 0. So right there. And then when we go 1 unit to the right, now up here, we saw that we went uh, up 1 unit. So now when we go 1 unit to the right, we're going to go up 3 units because we're multiplying by 3. So 1, 2, 3. And up here, so from this point, when we go 2 units to the right, we went up 1, 2, 3. Now we'll go up 9. So 2 units to the right, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there at the point 213. And so now as we think about up here, when we moved 1 unit to the left, we went up a half. So we're going to go up 1.5 when we move 1 unit to the left. So right there. Up here, when we went 2 units to the left, we went up a quarter. So now we're going to go up 3/4 because we're multiplying by 3 each time. And then that's going to get really close to the axis there pretty quickly. And it's going to look like that. So as we think about the inverse here, so again, we're reflecting across the line, y equals x. Let's draw that in there. And one thing we know right away about our uh, logarithmic function, because they're inverses of each other, these two functions, we know that our vertical asymptote has to be at x equals 1, because the vertical asymptote was at y equals 1 before in the original function f of x. And so now this point 0, 4 is 2 units across. 2 units across will go to 4, 0. This point right here, 1, 2, 3 diagonal units. 1, 2, 3 diagonal units. We'll put a point right there. And notice that this was at 1, 7, and this is at 7, 1. 1, 2, 3, 4, 5, 5.5 diagonal units. A half. 1, 2, 3, 4, 5 right here at 13, 2. Right there. All right. And now this is, it's a little harder to see the diagonal units. So we can think of this just as -1, positive 2.5. So it's going to be positive 2.5, -1 right there. And then this point right here is going to be -2, positive 1 3/4. So positive 1 3/4, or yes, positive 1 3/4, -2. So right there. All right, so now this is going to go like that. And There is our inverse function. So if you were given a logarithmic function and asked to graph it uh, without using a calculator, I'm not going to ask you to do that. But notice that your base of the logarithm is the base of the exponential. Inside your argument of the logarithm, whatever you're doing, multiplying or dividing, you do the opposite of it outside of the exponential. And whatever you're add or subtracting to it, you do the opposite of it outside there. So you can think of the inverse of your logarithm, which is the exponential. And then you can think about, well, I'm just going to reflect across the line y equals x and get your logarithm. So it's a little bit complicated, but the more practice you get, the better you get at it.